The world around us is filled with naturally occurring mixtures. Quite often, we might want to separate these mixtures into their components so that we can collect useful or precious chemicals. Find a mixture as two or more substances that have been physically and not chemically combined. Mixtures may contain combinations of gases, liquids, and solids that can be separated through physical means. In other words, the separation of a mixture involves a physical change. A physical change is a change in the physical properties of a substance that does not involve a change in its chemical composition. This means that a physical change does not involve chemical bonds being formed or broken. Examples include changing between the physical states of solid, liquid, and gas, dissolving into or precipitating out of solution, and physically separating the components of mixtures. We need to consider the physical properties of a mixture when selecting separation techniques. Physical properties include particle size, density, melting and boiling points, solubility, magnetism, and electrostatic attraction. In a mixture, pure substances retain their distinct physical properties, and any differences in these physical properties can be used to separate mixtures. In this lesson, we will focus on separation techniques that rely on differences in particle size and density. Sometimes, the major difference between two or more components in a mixture is particle size. As mentioned in our lesson on pure substances and mixtures, sieving is a separation technique where particles are separated by size. Substances with particles that are smaller than the holes in the sieve will pass through, while substances with larger particles will collect in the sieve. Remember our earlier video, Pure Substances and Mixtures? Blackbeard the pirate wanted to separate a heterogeneous mixture of gold coins and sand. If you recall, a heterogeneous mixture is a mixture that has variable composition and properties. In comparison, a homogeneous mixture is a mixture that has uniform composition and properties. To separate the gold coins from the sand, Blackbeard used a sieve that had holes smaller than the gold coins but larger than the sand particles. That way, the gold coins collected in the sieve while the sand fell to the ground. In some mixtures, the key difference between two or more pure substances is their density. Density is the mass of a substance per unit volume. We usually measure density in kilograms per cubic metre, or in grams per cubic centimetre. For example, water has a density of approximately 1 gram per cubic centimetre, while iron has a density of 7.8 grams per cubic centimetre. But beware, the mass or weight of a substance is not the same as its density. Density is the mass of a substance divided by its volume. If we consider a 1 kilogram chemistry textbook and 1 kilogram of feathers, they both have the same mass, 1 kilogram. But if you throw both of these into the ocean after your final exams, the chemistry textbook will sink while the feathers will float. This is because the 1 kilogram of feathers take up a much larger volume, so they have a lower density. Several separation techniques rely on differences in density, including sedimentation, decantation, centrifugation, and separation funnels. Sedimentation is a separation technique where insoluble particles suspended in mixtures are allowed to settle out from liquids or gases, often when the liquid or gas is stationary. In other words, if a solid particle cannot dissolve and is more dense than the surrounding mixture, then it will fall to the bottom. Sedimentation is often used to separate insoluble solids from mixtures containing insoluble solids and a liquid or gas. Liquid and gases can be referred to as fluids. When insoluble solids are separated from liquids, sedimentation is usually followed by decantation. Decantation involves pouring off a liquid from above insoluble particles that have settled at the bottom of a mixture. In other words, we can carefully pour out the liquid so that the more dense and insoluble solid remains at the bottom of the container. Let's see an application of this. Remember when Blackbeard accidentally tipped his boot full of sand into the last barrel of clean water? This resulted in a heterogeneous mixture of sand and water, which isn't very pleasant to drink. We know that sand has a higher density than water because sand sinks in water. Therefore, to separate clean water from sand, Blackbeard could use sedimentation followed by decantation. He could leave the mixture of sand and water to sit for a while, allowing the insoluble sand particles to settle out from the liquid water. Then he could carefully pour off the clean water from above the settled sand. Let's pause for a moment to look at the term miscibility. Miscibility refers to the ability of a liquid solute to dissolve in a liquid solvent. If two liquids are completely miscible, then we can mix them in any proportion to form a homogeneous mixture. For example, ethanol and water are miscible because we can make solutions using any concentrations of ethanol and water. If two substances are immiscible, then they cannot dissolve in each other, regardless of the proportions in which we mix them. Instead, they remain in two distinct layers, forming a heterogeneous mixture. For example, oil and water do not mix, whether we add a bit of water to oil or a bit of oil to water. Centrifugation is another separation technique that relies on differences in density. This involves rapidly spinning a mixture of substances that have different densities. Centrifugation can be used to separate solids and liquids if they have different densities. The more dense solids fall to the bottom of the container, while the less dense liquid floats on top. This process is essentially the same as sedimentation, except it occurs faster because the mixture is spun in a centrifuge. Centrifugation can also be used to separate immiscible liquids with different densities. The liquids separate into layers, with liquids of the highest density at the bottom of the container. Let's return to the pirate ship. The sun is rising, and Blackbeard tells Cookie, the ship's chef, to make the morning batch of coffee. Blackbeard likes his coffee brewed strong, with cream on top. Cookie takes out a carton of long-life milk and will use this to make the cream. Milk is a heterogeneous mixture containing fat, water, and other substances. Cookie can use centrifugation to separate the milk into layers. After spinning the milk around several times, the less dense fat particles float on top to be collected as cream, and the more dense substances, including water, sink to the bottom of the container. A separation funnel is a piece of laboratory glassware that is commonly used to separate two immiscible liquids of different densities. A mixture is poured into the separation funnel and the funnel is shaken. Afterwards, the mixture is left to settle inside the separation funnel. Over time, the more dense liquid settles to the bottom of the funnel, while the less dense liquid floats on top. The more dense liquid is run off through a tap at the bottom of the separation funnel, leaving the less dense liquid in the funnel. Shall we return to the pirate ship? Uh-oh, Cookie found a leak in the ship's stores. The barrels of lamp oil have water in them. They can't place this in their lamps because the water will put out the fire, leaving them unable to see at night. Luckily, water and oil are immiscible, so they can be separated using a separation funnel. Cookie could pour the mixture of water and lamp oil into a separation funnel and shake it. Once the mixture settles, the more dense water would rest at the bottom of the funnel, while the less dense lamp oil would float on top. The water could be run off through a tap at the bottom of the separation funnel, leaving pure lamp oil in the funnel. Let's revise the separation techniques that we've covered in this lesson. In the HSC chemistry course, you will need to know a range of separation techniques, the physical properties that they rely on, and when to apply each one. The physical properties of a substance include its particle size, density, melting and boiling points, solubility, magnetism, and electrostatic attraction. Sieving is a separation technique where particles are separated by size. Larger particles collect in the sieve, while smaller particles fall through. Density is the mass of a substance per unit volume. This is not the same as an object's mass or weight. Separation techniques that rely upon differences in density include sedimentation, decantation, centrifugation, and separation funnels. In each of these techniques, the more dense substance sinks to the bottom of the container, while the less dense substance remains at the top. Sedimentation is a separation technique where insoluble particles are allowed to settle out from liquids or gases, often when the liquid or gas is stationary. Decantation involves pouring off a liquid from above insoluble particles that have settled at the bottom of a mixture. Centrifugation involves rapidly spinning a mixture of substances that have different densities. A separation funnel is a piece of laboratory glassware that is used to separate two immiscible liquids of different densities. Immiscible fluids cannot dissolve in each other, such as oil and water.